Okay, this is the review, 8.4 through 8.6 for regular algebra 2 for the unit test. In number 1, we have to simplify the expression. So since there's nothing to factor because there's no addition or subtraction in either the numerator or the denominator, we can just cancel like terms. So we can take the 5 and the 25 and reduce. 5 goes into 25 5 times, so the 25 becomes a 5, the 5 becomes a 1. There's one a in the numerator and two a's in the denominator, so when we cancel out, you subtract exponents. So this is a to the first and this is a to the second, so 2 minus 1 is a. Since a is in the denominator is larger, we'll keep the a in the denominator. The numerator cancels. And b to the third is in the numerator, so b to the third divided by b to the second is just b, and that's in the numerator. The denominator will cancel out. So our final result, multiply everything in the numerator, 1 times b, which is 1b, over the denominator, which is 5a. And we can write just b over 5a. In number 2, before we cancel, we must factor first. We have addition and subtraction. You cannot cancel before you factor. So since this is two terms and it's not the difference of two squares, you have to factor using the GCF method. Since 10 and 15 have a common factor of 5 and x, we can factor out a 5x. Factoring out a 5x means we divide a 5x out of the 10x squared. So 10 divided by 5 is 2. And x squared divided by x is x. And then 15 divided by 5 is 3, and x divided by x is just 1, so we don't need to write that. The denominator is factored by taking out a GCF. 35 and 5 have a common factor of 5. X squared and x have a common factor of x. So again, we can factor out a 5x. Dividing out 5x from 35x squared gives us a 7x. Keep the minus sign. 5x divided by 5x is 1. Now, since we have common factors of 5x, we can cross those out, and our final answer is 2x plus 3 divided by 7x minus 1. Okay, number 3. The numerator can be factored. Again, it's two terms, so we look for difference of squares. Since we don't have perfect squares, we're using the GCF method. Divide out a 2. Divide out a 2 from 2x. You're left with x minus 3 over, again, difference of squares we do not have because an x to the third is not a perfect square. So we'll take out the GCF, which is x squared. 3x squared divided by x squared is just 3 minus x. Now we have a problem because these look like the same, but they're not. In the numerator, x is positive and the 3 is negative, but in the denominator, the x is negative and the 3 is positive. Now if we could change the signs, this would be negative and this would be positive, which gives us exactly what we have in the denominator. So we can do that by factoring out a negative 1. If you take out the negative, the x now becomes negative and the 3 becomes positive. Now we have a negative x in both the numerator and the denominator and a positive 3. These now will cancel and we can reduce down to negative 2 over x squared. In number 4, y squared plus 6x plus 9 can be factored by y and y giving you y squared, and 3 and 3 multiplied to 9, and they have to be both positive to add to a positive 6. The denominator can be factored. I'm going to use my friends up here to help me. I'm going to guess that a y plus 3 will be a factor since the numerator has a y plus 3 in it, and I'm going to try to get this factor over here based on my y plus 3. So if I have a y here, to get 2y squared, I need a 2y. 2y times y is 2y squared. Now I have a 3 here, and I need another number to multiply to 15. So if I have a 3 I'm going to need a 5. Now I need a negative 15, so this would have to be a negative 5. So let's check to make sure this works. We get a negative 5y and a positive 6y. When we add that, we get a 1y, which is exactly what we need. So this works. Okay. We can cancel out common factors. The y plus 3 is a common factor. So the final simplified answer is y plus 3 over 2y minus 5.